Alright, this is the classic dynamic programming problem, finding the subarray with the largest sum. At first you might think, do I need to check every possible subarray? That'd be O of n squared and way too slow. Here's the key insight: at every position in the array, you only have two choices: either extend the current subarray, or start fresh right here. That's Cadon's algorithm, and it's absolutely beautiful in its simplicity. We start by initializing two variables, both set to the first element. Max_sum is our global best, the largest subarray sum we've found so far across the entire array. Current_sum tracks the best sum of any subarray that ends at our current position. We use nums, 0, instead of 0 because what if all numbers are negative? We still need to return the least negative one. Now we loop through the array starting from index 1, since we already used the first element for initialization. Each iteration, we're standing at a new number and asking ourselves one simple question: should I keep building on what I had, or cut my losses and start over? That's the entire algorithm in one sentence. This is where the magic happens. We take the max of two options, just the current number by itself, or the current number added to our running sum. Think of it like a road trip. If your journey so far has been terrible and dragging you down, you're better off just starting a brand new trip from where you are. If current_sum was negative, adding it to number would only hurt us, so we'd start fresh. After we decide the best subarray ending at this position, we check, is this better than anything we've seen before? We take the max of our previous best and the current running sum. This way, max_sum always holds the answer to our problem at any point during the traversal. Super simple, right? Once we've walked through every element, max_sum contains the largest subarray sum we ever encountered. We just return it. Notice we never needed to store the actual subarray or use any extra arrays, just two simple variables carried us through the entire solution. Time complexity is O of n, one single pass through the array, that's it. Space complexity is O of 1 since we only use two extra variables regardless of input size. Here's your takeaway: Cadon's algorithm boils down to one question at every step: is my past helping me or hurting me? If it's hurting, drop it and start fresh. That's not just good algorithm design, that's good life advice.